In a single outburst, Eta Carinae released more energy than the Sun has in its entire lifetime. But it didn't stop there. It continues to battle against its own fate. How is it possible that such a cosmic monster still exists, despite its violent episodes? What forces keep at bay an explosion that seems imminent for centuries? And why do astronomers consider it one of the greatest ticking time bombs in the universe? The story of Eta Carinae is that of a survivor, marked by spectacular eruptions and enveloped in a gigantic cloud of gas and dust that it itself expelled into space. It is a natural laboratory, so strange and dangerous that studying its behavior is like trying to decipher the mind of a volcano about to erupt. Its light has fluctuated with such intensity that in the 19th century it became one of the brightest objects in the night sky, only to fade and reappear with renewed fury. What internal mechanisms trigger these incomplete outbursts, and what can they teach us about the fate of the most massive stars? Observing Eta Carinae is peering into a cosmic process in slow motion, where destruction and creation intertwine in an unparalleled spectacle. Its mass defies known limits, its binary system is a dangerous dance of two titans, and its history is filled with mysteries yet to be solved. Are we witnessing the prelude to a supernova that will shake our galaxy, or will Eta Carinae continue to resist, defying astronomers' expectations and rewriting what we thought we knew about the cycle of stellar life? Get ready to explore one of the most fascinating and explosive stories in the known universe. What makes Eta Carinae so special? It's not just another star in the sky, it's one of the most massive, luminous, and violent objects we know of in the Milky Way. To understand its nature, one must first imagine a star that defies all the limits known to astrophysics. Eta Carinae is a hypergiant star, and its mass exceeds that of the Sun by more than 100 times. But mass isn't everything. Its brightness is so powerful that if it were as close to us as Sirius, it would be capable of casting shadows on Earth at night. Why do astronomers consider it such an enigmatic star? Eta Carinae stands out not only for its size, but also for its instability. It behaves like a cosmic volcano, capable of releasing immense amounts of energy in explosive episodes, though without completely destroying itself. Unlike typical stars, which tend to live quietly for millions of years, Eta Carinae lives on the edge of collapse, alternating periods of calm with eruptions so violent that they can temporarily outshine all nearby stars. Is Eta Carinae a solitary star? Interestingly, it is not. It is part of a binary system, accompanied by another massive star that orbits it in a dangerous and complex gravitational dance. This close relationship generates chaotic interactions, further fueling its instability and mysterious behaviors. In fact, it is precisely this relationship that contributes to making Eta Carinae so unpredictable, turning it into a natural laboratory for studying the extremes of stellar physics. But why do we study it with such interest? Stars like Eta Carinae are true engines of change in the universe. Their stellar winds and explosions reshape the space around them, scattering heavy elements that will eventually form new stars and planets. Understanding Eta Carinae is peering into the future of the most massive and explosive stars in the cosmos, as well as the past of our own solar system, whose ingredients were once forged in similar cataclysms. Thus, Eta Carinae is not just a star, it is a living clue to how the universe reinvents itself in an eternal cycle of destruction and creation. Where is Eta Carinae located in the vast stage of the universe? To answer this question, we must first position ourselves in our own galaxy, the Milky Way. This gigantic spiral structure houses hundreds of billions of stars, and within one of its arms, called the Carina Sagittarius arm, lies our protagonist, Eta Carinae. But how far is it really from us? If we could travel in a straight line towards it, we would have to cover about 7,500 light-years. That is to say, the light we see today from Eta Carinae began its journey when ancient civilizations were just emerging on Earth. To put this distance into perspective, imagine that the Milky Way is a vast city and our solar system is a house in a quiet neighborhood. Eta Carinae would be an imposing building, visible from afar, located in another neighborhood of the city. It is not our immediate neighbor, but its presence is so powerful that even at this distance, it manages to catch the attention of astronomers. Its precise location is in the southern sky, within the constellation of Carina, also known as the Keel, a region rich in nebulae and star clusters. And why is its location so relevant? Eta Carinae is immersed in one of the most active star formation areas of the galaxy. The Carina Nebula, where it resides, is a true star factory, a place where interstellar gas and dust continuously transform into new suns. Eta Carinae's proximity to these stellar nurseries makes it an important player in the dynamics of the region, influencing its surroundings with its energy and winds. Moreover, Eta Carinae's position in the southern sky means it can only be observed from the southern hemisphere or from latitudes close to the equator. For many inhabitants of the planet, this star remains a mystery hidden by the horizon, adding an aura of exclusivity and intrigue to its study. Thus, its location, both in the galaxy and in the firmament, has shaped the way science observes and understands it, making it a distant yet fascinating jewel of the cosmos.
If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey.
How can a star go from being invisible to becoming one of the most observed objects in the sky? Thus begins the fascinating story of Eta Carinae, whose existence challenged astronomers for centuries. In the early years of the 18th century, stellar catalogues did not mention any prominent star in the region where Eta Carinae now reigns. It was as if the star had been asleep, waiting for its moment to shine. It was not until 1731 that the French astronomer Nicolas Louis de Lacaille identified it and included it in his records. But even then, Eta Carinae did not stand out particularly. What happened for a star to go from obscurity to astronomical fame? The answer lies in an astonishing transformation. During the first half of the 19th century, Eta Carinae began to increase its brightness unexpectedly. Between 1837 and 1845, the star put on an unparalleled show. It became so luminous that it was the second brightest star in the night sky, surpassed only by Sirius. Imagine a star that suddenly eclipses almost all the others in the celestial vault. This phenomenon caught the attention of astronomers from around the world, who began to study it with a mix of wonder and bewilderment. What could cause such an explosion of light? Observing Eta Carinae at that time was no easy task. Telescopes were still rudimentary and recording techniques limited. However, the most passionate astronomers, like John Herschel, meticulously followed the star's behavior from the southern hemisphere. Herschel, in particular, documented the changes in brightness and described details of the nebulosity that began to surround it, laying the groundwork for the future understanding of this unique system. Reports from that era mixed scientific rigor with the awe of those witnessing a completely unexpected cosmic phenomenon. As the decades passed, interest in Eta Carinae did not wane. The star lost brightness after its great eruption, nearly disappearing from the naked eye. However, its mysterious variability and the gradual formation of a nebula around it made it a permanent object of study. Thus, the story of its discovery and early observations not only reflects the evolution of astronomy, but also humanity's ability to marvel at and question the mysteries of the universe. What secrets would Eta Carinae continue to hold? Each generation of astronomers has tried to answer that question, driven by the same curiosity that sparked that sudden burst of light in the 19th century. What makes the Carina Nebula so special? Much more than just a backdrop for Eta Carinae, this immense cloud of gas and dust is one of the most active stellar nurseries in our galaxy. If it could be compared to something on Earth, it would be like a gigantic cosmic incubator, where thousands of stars are born, evolve, and sometimes die spectacularly. But why do astronomers spend so many hours studying it? The answer lies in its richness. The Carinae Nebula contains some of the most extreme and energetic phenomena we can observe without leaving the Milky Way. Did you know that the Carinae Nebula is almost 4 times larger and brighter than the famous Orion Nebula? It stretches over 200 light-years and is so filled with new stars and interstellar material that when viewed through powerful telescopes, it looks like a storm in full development. There, stellar winds and radiation from massive stars sculpt whimsical shapes, creating columns, bubbles, and filaments that defy imagination. It is a constantly changing landscape where violence and beauty coexist in balance. But what is the relationship between Eta Carinae and this nebula? Imagine Eta Carinae as the engine of a cosmic hurricane. Its energy and eruptions have shaped the surrounding environment, pushing and heating the gas of the nebula, triggering the formation of new stars in the surrounding regions. The past explosions of Eta Carinae have left deep marks, creating cavities and shock waves that can still be traced. Thus, the Carinae Nebula is not only home to Eta Carinae, but also a witness and product of its violent history. Can a single star change the fate of an entire cloud of gas and dust? In the Carinae Nebula, the answer is a resounding yes. The interactions between Eta Carinae and its environment have given rise to unique structures, such as the famous fingers and towers of gas, which often signal the birth of new stars. This feedback process is crucial for understanding how galaxies evolve and how cosmic material is recycled. In the heart of the Carinae Nebula, the life and death of stars are inextricably intertwined, reminding us that in the universe, everything is connected through cycles of destruction and creation. What makes Eta Carinae so special in the universe of stars? To begin with, its mass defies our imagination. The primary star of this system is estimated to have between 100 and 150 times the mass of our Sun. It's not just a simple giant, it's a true stellar colossus. If the Sun were an apple, Eta Carinae would be like a stack of watermelons piled up to the ceiling. This enormous mass is the key to its unstable nature and the extreme phenomena surrounding it. The luminosity of Eta Carinae is also overwhelming. How bright is it really? It is estimated that its glow is equivalent to several million times that of the Sun. If Eta Carinae were at the same distance from Earth as our star, its light would be so intense that it would likely destroy any form of life on the planet. This colossal energy not only illuminates the surrounding space, but also drives stellar winds so powerful that they can strip entire layers of its own material and launch them into interstellar void. Its surface temperature ranges between 30,000 and 40,000 degrees Celsius, much hotter than the solar surface, which hovers around 5,500 degrees. These extreme temperatures cause the star to emit large amounts of ultraviolet radiation, invisible to our eyes, but crucial for understanding the violent reactions occurring in its atmosphere. Why is this radiation so important? Because it plays a fundamental role in shaping its environment and in the formation of structures like the famous Carinae Nebula. But there's more. The gravity on the surface of Eta Carinae is so intense that, despite the force of its winds, only the outermost layers manage to escape into space. The inner layers, on the other hand, remain trapped in a constant struggle between outward pressure and inward gravity. Moreover, the star is losing mass at a dizzying rate. Each year, it ejects into space material, equivalent to several times the mass of the Earth. This process, far from being silent, leaves visible traces in the cosmos and contributes to its reputation as a star in constant eruption. Finally, one of the most intriguing characteristics of Eta Carinae is its instability. It is not a calm star, but a natural laboratory where physical laws are pushed to the limit. It changes brightness, expels material, and defies astronomers' predictions. Will it hold together for much longer, or is it doomed to a spectacular explosion? The physical properties of Eta Carinae make it one of the most fascinating and dangerous objects in our galaxy, a true cosmic time bomb whose countdown no one can predict with accuracy. Did you know that Eta Carinae is not a single star, but at least two stellar giants caught in an extreme gravitational dance? At first glance, it may seem like a solitary star, but in reality, it is a binary system formed by two massive stars, each with characteristics so extreme that they challenge our imagination. This pair orbits each other in a cycle that lasts approximately 5.5 years, and during that time, their interaction creates one of the most violent and fascinating spectacles in the galaxy. The main star of the system is one of the most massive and luminous known in the Milky Way, with an estimated mass between 100 and 200 times that of the Sun. Its companion, although less massive, is also a very hot and energetic giant. Together, their interaction generates stellar winds so powerful that when they collide, they produce shocks capable of releasing astonishing amounts of energy. Can you imagine two cosmic hurricanes continuously crashing into each other? That's how chaotic the environment around Eta Carinae is. But why is it so important that Eta Carinae is a binary system? The presence of a companion radically alters the evolution of both stars. The gravity they exert on each other changes the way they lose mass, the structure of their stellar winds, and even the way they shine. For example, during the closest point of their orbit, the winds from the two stars collide with such force that the system emits intense bursts of X-rays, a phenomenon that astronomers study to better understand the extreme physics of these objects. This relationship is so tumultuous that every time the stars come close, there are huge variations in the brightness and energy emission of the system. Scientists believe that these violent interactions have influenced the historical outbursts of Eta Carinae and the shape of the surrounding nebula. Observing this binary system is like watching a game of chess on a cosmic scale, where every move has dramatic consequences for the ultimate fate of both stars. Thus, the enigma of Eta Carinae lies not only in its individual power, but in the complex and dangerous relationship between its two components. What makes a star go from calm to fury in just a few years when its life is measured in millions? Eta Carinae starred in one of the most dramatic events ever witnessed in the sky, the so-called Great Eruption of the 19th century. Between the years 1837 and 1858, this massive star transformed so radically that it shone brighter than any other star in the sky, except for Sirius. But what triggered such an explosion of energy? Astronomers are still debating the exact causes, but it seems to point to a gigantic loss of mass, a kind of failed explosion that left the star on the brink of ultimate catastrophe, though it never became a supernova. During this period, Eta Carinae expelled a colossal amount of material into space, equivalent to tens of times the mass of our Sun. To put it into perspective, it's as if an entire mountain of matter was launched into the void every day for over 20 years. The result was the formation of a dense and bright nebula that, centuries later, still stands as a witness to that episode. What was going through the minds of the astronomers of the time as they witnessed this radical change in the sky? Many thought they were witnessing the birth of a new star or a cosmic signal of unknown importance. The Great Eruption not only surprised with its sudden increase in brightness, but also with its duration. While most stellar eruptions resolve in a matter of days or weeks, this phenomenon lasted for over 2 decades. Why did it last so long? The most accepted explanation is that the interaction between the outer layers of Eta Carinae and the extreme gravity was so violent that the material did not escape all at once, but in successive waves. Thus, the star survived a catastrophe that, under different circumstances, would have ended its existence in a matter of seconds. The legacy of the Great Eruption is fundamental to modern astronomy. Thanks to this event, scientists have been able to closely study how a massive star can lose a significant portion of its mass before ultimately exploding. Moreover, the peculiarity of Eta Carinae offers a unique window to understand the processes leading up to supernovae, those final explosions that recycle heavy elements in the universe. Are we witnessing a star that resists its final fate? Or are we simply observing a pause before the ultimate explosion? The answer remains one of the great enigmas of astrophysics. What happens when a colossal star experiences one of the most violent explosions without being completely destroyed? In the case of Eta Carinae, the result was the formation of the homunculus nebula, one of the most enigmatic and photogenic structures in the cosmos. But what exactly is the homunculus nebula, and how did it come to exist? To understand this, we must go back to an extraordinary episode in the history of this star. An eruption so powerful that it expelled an amount of material equivalent to several times the mass of our Sun, but surprisingly, it did not end the life of Eta Carinae. The homunculus nebula is, in essence, a gigantic bubble of gas and dust thrown into space. Its name, which comes from Latin and means little man, alludes to its peculiar bilateral shape, resembling a doll or two symmetrical lobes emerging from a central point. But why does it have that shape? The answer lies in the extreme physics of the star itself. During the Great Eruption, the material was not expelled uniformly, but shot out along the poles of the star, as if Eta Carinae had launched two opposing jets of gas at incredible speeds, close to 600 kilometers per second. This polar expulsion created the two main lobes and left a thinner equatorial zone, almost like the waste of a cosmic hourglass. And why are we so fascinated by the homunculus nebula? On one hand, it acts as a real-time record of what happens when a massive star goes into crisis. The light we see reflected in the nebula is, in fact, a time capsule, part of the original radiation from the Great Eruption, which has been absorbed and re-emitted by the dust particles, allowing us to study an event that occurred over a century ago. Furthermore, the homunculus allows astronomers to analyze the chemical composition of the expelled material, finding heavy elements that can only form in the hearts of giant stars, which will later become the seeds of new planetary systems. But the homunculus is not just a visual spectacle. It is a natural laboratory for understanding the final stages of the most massive stars. What does its structure tell us about the violence of the explosion? Why did Eta Carinae manage to survive despite losing so much mass? Each of its whimsical folds and filaments hides clues about the mechanisms that govern stellar eruptions. As scientists observe how the homunculus evolves, they can anticipate what the future holds for Eta Carinae and other similar stars, as well as the fate of the elements that may one day form planets or even life in other corners of the universe. In short, the homunculus nebula is much more than a cloud of gas. It is the silent testimony of a colossal internal battle, a luminous scar that speaks to us of the extremes to which nature can reach. Its study not only reveals the secrets of Eta Carinae, but also brings us closer to understanding the most powerful and mysterious processes of the cosmos. Why doesn't Eta Carinae shine consistently? That is one of the questions that fascinates astronomers the most. Unlike the calmer stars we know, Eta Carinae is famous for its extreme variability. Its brightness can dramatically increase or decrease within years, months, or even days. But what causes these remarkable changes? The answer lies in the unstable and chaotic nature of this colossal star, whose life is anything but tranquil. Throughout history, Eta Carinae has become one of the brightest stars visible in the night sky, only to fade away and go unnoticed. This behavior is so unusual that if Eta Carinae were a lighthouse, it would be as if its light flickered randomly, sometimes blinding sailors and other times plunging them into darkness. Is it possible for such a massive star to simply decide to change its light intensity? In reality, these changes are the result of violent internal processes, such as partial explosions in its outer layers and the intense gravitational interaction between the stars that make up its binary system. The variability of Eta Carinae manifests not only in the visible spectrum, but also in other ranges of the electromagnetic spectrum, such as X-rays. For example, every time the two stars that form the system come closer in their orbit, their stellar winds collide with tremendous force, generating bursts of energy that cause the brightness to change suddenly. It's as if two cosmic hurricanes collided head-on, releasing immense amounts of energy in the process. These events have been carefully observed by astronomers who have detected cyclical patterns in the variability of Eta Carinae, although surprises always arise that challenge predictions. Why is it so important to study these changes in brightness? Because they provide clues about what happens inside a star on the brink of destruction. Each fluctuation is a window into processes we do not fully understand, from massive material loss to unstable nuclear fusion phenomena. The variability of Eta Carinae is ultimately a reminder that the universe is filled with unpredictable and astonishing objects, and that even such gigantic stars can behave whimsically and unexpectedly. What would happen if one of the most massive and volatile stars in the nearby universe were about to explode? Eta Carinae, with its impressive instability and a history filled with colossal eruptions, is a strong candidate to star in one of the greatest cosmic spectacles, a supernova. But is it really that close to that fate? Astronomers have been wondering for decades when the inevitable end of Eta Carinae will occur, and although no one can pinpoint the exact date, everyone agrees that the outcome will be as spectacular as it is devastating. To understand the future of Eta Carinae, we must first remember that it is a star with a mass greater than 100 times that of the Sun. Such massive stars have short and tumultuous lives, as if they burn the candle at both ends. The nuclear fuel in their core is consumed at a fierce rate, unleashing cycles of instability and violent expulsions of matter. Does this mean that the explosion is imminent? In astronomical terms, soon can refer to any moment within the next few thousand years. From a human perspective, that might seem like an eternity, but for the universe, it is merely a whisper. What is fascinating is that Eta Carinae has already shown signs of being in its final chapters. The gigantic amount of mass it has lost in previous eruptions, combined with the intensity of its stellar winds, makes it clear that the structure of the star is on the brink of collapse. Astrophysical models predict that, when the time comes, Eta Carinae could explode in a supernova so bright that it would be visible even in broad daylight from Earth. Some scientists even propose the possibility of a hypernova, an even more energetic explosion capable of releasing more energy in seconds than the Sun has in its entire existence. But what consequences would this event have for our planet? Although Eta Carinae is more than 7,500 light-years away, a supernova of such magnitude could affect Earth in indirect ways, such as an increase in cosmic rays or a possible alteration of the ionosphere. However, experts agree that it does not pose a direct threat to life on Earth. Rather, its explosion would be a unique opportunity for science. It would allow us to study in real time the most extreme processes of stellar evolution, shed light on the formation of heavy elements, and perhaps answer one of the most intriguing questions in astronomy. How do the most massive stars in the cosmos really die? Thus, the future of Eta Carinae remains shrouded in a veil of uncertainty and anticipation. Will it be tomorrow, in 1,000 years, or perhaps longer? No one knows for sure. The only certainty is that when the time comes, the explosion of Eta Carinae will be one of the most impressive phenomena humanity has ever witnessed, reminding us how small we are in the face of the immeasurable power of the universe. When we think of massive stars, we might imagine that they are all similar, giant, hot, and bright. But what makes Eta Carinae stand out among these cosmic monsters? To understand this, let's compare Eta Carinae with other colossal stars that populate our galaxy. For example, Rigel in the constellation Orion is a famous blue supergiant, but its mass is barely a fraction of what Eta Carinae possesses. While Rigel has about 20 times the mass of the Sun, Eta Carinae is estimated to exceed 100 times the solar mass. It's like comparing an elephant to a mythological colossus. Another star that often comes up in conversation is Betelgeuse, the famous red supergiant visible to the naked eye in the night sky. Betelgeuse is enormous in size, so much so that if it were in the place of the Sun, it would swallow Mars's orbit. However, in terms of mass and luminosity, Eta Carinae far surpasses it. The energy that Eta Carinae releases in a single year is equivalent to the energy produced by the Sun over several millennia. In fact, Eta Carinae is one of the most luminous stars ever observed in the Milky Way. Now, what about other stars famous for their extreme behavior? Let's think of stars like Pistol Star, or the hypermassive R136A1. R136A1, located in the Large Magellanic Cloud, is even more massive than Eta Carinae, with a mass that could reach up to 300 times that of the Sun. However, Eta Carinae stands out for the violence of its eruptive episodes and its instability, traits that not all massive stars share to that degree. It's as if Eta Carinae is on a cosmic roller coaster, on the verge of losing control at any moment. But why do some massive stars explode suddenly, while others, like Eta Carinae, seem to do so slowly and in stages? The answer lies in their internal structure and how they lose mass. While many massive stars end their lives in a rapid and spectacular explosion, Eta Carinae has lost enormous amounts of mass through violent eruptions, thereby delaying its final fate. Additionally, its binary nature adds complexity. The gravitational interaction and stellar winds between both components make its evolution much more chaotic and unpredictable than that of other giant stars. In summary, although it shares the category of massive star with other titans of the cosmos, Eta Carinae is unique for its combination of mass, luminosity, instability, and its tendency to defy astronomers' expectations. What secrets can a distant and powerful star like Eta Carinae hide? The answer lies, in large part, in the light it emits. But it's not just about the visible light we could capture with our eyes. Eta Carinae is like an orchestra playing at multiple frequencies, and each instrument reveals a distinct facet of its nature. The electromagnetic spectrum allows us to hear all those instruments at once, from the lowest notes of infrared to the extreme highs of gamma rays. Why is it so important to observe it in so many different wavelengths? When astronomers analyze the electromagnetic spectrum of Eta Carinae, they discover that its energy is not limited to a single type of light. In the visible range, the star is already an impressive sight, but its true power is unveiled in other frequencies. For example, in the ultraviolet, Eta Carinae shines with an enormous intensity, showing signs of extremely high surface temperatures and violent processes in its atmosphere. It's like seeing the fire beneath the surface of a volcano, barely contained and constantly erupting. But the story doesn't end there. By observing it in X-rays, scientists find evidence of titanic collisions between stellar winds. Imagine two colossal hurricanes colliding with each other at unimaginable speeds. That violence generates X-rays that we can detect from Earth. Additionally, in radio and infrared frequencies, Eta Carinae reveals the presence of coal dust and gas surrounding the system, remnants of ancient eruptions, and material expelled in catastrophic events. Each range of the spectrum is like a different layer of the star's past and present. And what about gamma rays? At this end of the spectrum, Eta Carinae proves to be even more extreme than it seems. Gamma ray observations have revealed periodic emissions related to the interactions between its two massive stars and the acceleration of particles at speeds close to the speed of light. It's as if Eta Carinae is sending coded messages to the universe, informing about its most energetic and mysterious processes. Thus, the study of the electromagnetic spectrum of Eta Carinae not only shows us a star, but also a natural laboratory where the most fundamental laws of physics are tested. What makes Eta Carinae so special? besides its size and explosive history? One of the most surprising answers lies in its extreme stellar winds, true cosmic hurricanes that defy everything we imagine about natural forces. But what does it mean for a star to have winds, and why are those of Eta Carinae so colossal? Stellar winds are flows of charged particles that break away from a star's surface and expand into space at incredible speeds. In the case of Eta Carinae, these winds reach speeds of up to 3 million kilometers per hour, enough to cover the distance between the Earth and the Moon in less than a minute. It's as if Eta Carinae is constantly throwing part of itself into the universe, like an endless storm of matter and energy emanating from its depths. Why does a star generate such powerful winds? It all begins with the enormous pressure and temperature in its core, which generate radiation so intense that it literally pushes matter outward. Compared to our Sun, the winds of Eta Carinae are at least 1,000 times stronger. The star loses an amount of mass each year equivalent to several times the mass of the Earth. This mass loss not only affects the star, but also shapes the environment around it, sculpting nebulae and generating shockwaves that heat the surrounding gas to extreme temperatures. And what consequences does this have for the stellar system and the nearby space? The stellar winds of Eta Carinae not only disperse matter, but also influence the formation of new stars in the region. When they collide with nearby interstellar material, these winds can compress gas clouds, triggering the birth of new stars. But at the same time, the violence of these bursts can sweep away gas and prevent new stellar generations from forming in certain areas. It's a delicate balance between destruction and creation, where the force unleashed by Eta Carinae is capable of shaping the cosmic landscape for millions of years. An even more fascinating phenomenon occurs when the winds from both stars in the Eta Carinae binary system collide. These collisions produce regions of extremely high energy, where matter is heated to millions of degrees and emits powerful X-rays. It's as if a constant battle between stellar titans is raging at the heart of the Carina Nebula, releasing energy that we can detect even from Earth. Ultimately, the extreme winds of Eta Carinae are not just an astronomical curiosity, but also a window into the most violent and creative processes of the universe, reminding us that even amidst chaos, new forms of life and light can emerge. How does such an extraordinary star as Eta Carinae come to be? It all begins in the depths of a gigantic cloud of gas and dust known as a molecular nebula. There, gravitational forces initiate a slow but relentless collapse, compressing the matter until a dense and hot core is formed. In this extreme environment, pressure and temperature rise to such an extent that the nuclear engine ignites, the fusion of hydrogen into helium. But in the case of Eta Carinae, the amount of available material was so colossal that, from its birth, it was destined to be one of the most massive and brightest stars in the galaxy. As Eta Carinae evolved, its life turned out to be anything but tranquil. Massive stars like this consume their fuel at an astonishing rate, as if they were in a race against time. Instead of living billions of years like our Sun, Eta Carinae will only have an existence of a few million years. Why does this happen? Because the larger the star, the faster it burns. It's like comparing a small campfire to a huge bonfire. The larger one consumes much more oxygen and firewood, and while it dazzles more, it goes out much sooner. But the story of Eta Carinae is not just that of a giant star, but also of a constant struggle to stay intact. Its enormous mass generates stellar winds so powerful that they expel matter into space at incredible speeds. These winds have shaped the environment around the star, sculpting clouds and bubbles of gas that we admire from Earth today. Furthermore, the interaction with its companion in the binary system has caused instabilities and colossal eruptions, as if the star were in a perpetual state of turmoil. What triggers these titanic explosions? The answer lies in the delicate balance between the gravity that tries to keep it cohesive and the radiation pressure that seeks to disperse it. The evolution of Eta Carinae is a race toward the abyss. After exhausting the hydrogen in its core, the star began to fuse heavier elements like helium, carbon, and oxygen, each stage faster and more chaotic than the last. This process is like a countdown to an inevitable fate, a violent death in the form of a supernova, or even something more extreme, like a collapse into a black hole. However, what is fascinating is that Eta Carinae has not yet reached that grand finale. Its formation and evolution show us how nature can create, transform, and eventually destroy the most colossal bodies in the universe, leaving behind new seeds for future generations of stars. What do one of the most unstable stars in the universe and human imagination have in common? Eta Carinae has managed to transcend the boundaries of science to become a recurring figure in popular culture. But why has such a distant star captured the attention of writers, artists, and creators around the world? Its explosive history and uncertain future have served as inspiration in science fiction literature, where it often represents the archetype of the unpredictable star, capable of altering the fate of entire civilizations. Some authors have described it as a cosmic hourglass, a symbol of time running out, and a reminder that even celestial titans can disappear in an instant. In film and television, Eta Carinae is often mentioned in stories about cosmic disasters and interstellar journeys. In various documentaries and animated series, it is named as the ideal setting to explore the limits of human knowledge and the dangers of space exploration. Can a star become a central character? In the case of Eta Carinae, its presence is so imposing and mysterious that it is often treated almost like a living entity, capable of influencing the plot as much as any protagonist. The world of video games has not been immune to its magnetism either. Some space titles have used Eta Carinae as a key location, presenting it as a forbidden destination or a landmark for risky missions. What makes this star so attractive to developers? Its reputation for instability and its potential to explode at any moment make it the perfect backdrop for extreme challenges and high-stakes adventures. Thus, science merges with creativity, transforming Eta Carinae into a driving force for stories that combine awe for the real universe with the thrill of the imagined. Even in music and visual art, Eta Carinae has left a mark. Composers have dedicated pieces to its explosive dance, and artists have used its image to represent concepts of transformation, destruction, and rebirth. Is it possible for a star to inspire such deep human emotions? The answer seems to be yes. Its dramatic nature and its role as a giant on the edge of the abyss make it a modern muse, a brilliant reminder of how small and fleeting we are in the face of the grandeur of the cosmos. In this way, Eta Carinae not only illuminates the sky, but also the creativity and curiosity of those who look up seeking answers and new stories. Why does a star like Eta Carinae fascinate astronomers and astrophysicists so much? The answer lies in its role as one of the best natural laboratories for studying the extremes of the universe. Eta Carinae is much more than just a massive star. It is a factory of cosmic phenomena that allows us to explore the most violent and mysterious processes that can occur in the cosmos. Thanks to its colossal size, instability, and relative youth, scientists can observe in real time how a star lives on the edge of known physics. What makes Eta Carinae so special for astrophysics when there are millions of stars in the sky? The key lies in its rarity and the variety of processes surrounding it. It converges stellar winds so intense that they surpass almost any other known object. Interactions between massive stars in binary systems and partial explosions that challenge traditional explanations of stellar life. It's like having a laboratory where all the ingredients mix to generate unique experiments impossible to reproduce on Earth. Many of the great mysteries of stellar evolution find in Eta Carinae a perfect setting for investigation. How do the most massive stars lose mass before exploding? How do stellar winds influence the interstellar medium, seeding new elements throughout the galaxy? Eta Carinae, with its eruptions and constant instability, allows scientists to measure these processes and test theories that would otherwise be mere hypotheses. Every piece of data collected from this system helps to understand how the most giant stars in the universe are born, evolve, and die. Moreover, Eta Carinae offers key clues about the final fate of supermassive stars and the origin of some of the heaviest elements that exist. Could its future explosion teach us how the most massive black holes form? What kind of supernova will it leave as a legacy? The answers to these questions have a direct impact on our understanding of galactic evolution and the cycle of matter in the universe. For all these reasons, Eta Carinae is much more than a star. It is a true treasure for modern astrophysics, a privileged window into the deepest secrets of the cosmos. How can we study a star as distant and mysterious as Eta Carinae from our small planet? Although it is over 7,500 light-years away, astronomers have developed ingenious ways to observe it and decipher its secrets. Since the 19th century, telescopes located on the Earth's surface have been the eyes that allowed us to discover its brightness changes and unpredictable nature. But what are the challenges of looking so far and through the dense Earth's atmosphere? The atmosphere distorts and absorbs part of the light coming from space, so scientists have had to seek privileged locations for their observatories, such as mountain peaks or deserts, where the air is more stable and clean. Optical telescopes have been essential for recording the luminosity changes of Eta Carinae, allowing us to document its eruptions and variations over time. But it's not just visible light that tells the story. Telescopes equipped with special detectors can capture ultraviolet and infrared radiation, opening a window to phenomena hidden by interstellar dust. For example, infrared observation allows us to see through the dust clouds surrounding the star, revealing details about the structure of the nebula that envelops it. Thus, each type of light contributes a distinct piece to the complex puzzle that represents Eta Carinae. And what happens when the phenomena we want to study can only be captured at higher energies, like X-rays? For this, astronomers have used space telescopes, but they have also installed special detectors on stratospheric balloons and modified airplanes that fly above most of the atmosphere. Furthermore, thanks to international collaboration, there are networks of ground-based observatories that monitor the star in a coordinated manner, ensuring that no significant event goes unnoticed. This constant surveillance has allowed the detection of collisions of stellar winds, unusual brightness variations, and even signals of possible future explosions. Observing Eta Carinae from Earth is like trying to listen to a conversation in a noisy crowd. But with patience, technology, and creativity, astronomers have managed to decipher crucial messages about the life and evolution of one of the most extreme stars in our galaxy. Every piece of data collected from our observatories is a window into the universe's past, demonstrating that although our perspective is small compared to the vastness of the cosmos, human curiosity can overcome any distance. What makes Eta Carinae one of the most photographed and studied stars in the universe? The answer lies in the truly stunning images generated by its surroundings. Each photograph captured by telescopes reveals details that seem straight out of a science fiction work. For example, the structure of the Homunculus Nebula, formed after the Great Eruption, appears like a kind of cosmic butterfly, with two gigantic and symmetrical lobes extending into space, as if the star had exhaled two enormous bubbles of gas and dust. But why this peculiar shape? Scientists deduce that the violent stellar winds and the interaction between the components of the binary system have sculpted this spectacular scene, capturing the gaze of astronomers and enthusiasts around the world. The colors of Eta Carinae are also astonishing. When astronomers observe the star and its nebula at different wavelengths, vibrant colors emerge that the human eye could never perceive at a glance. Blue, green, and reddish tones paint the space, a result of ionized gases and collisions between stellar winds. Did you know that these images are not only beautiful, but each color reveals key information about the chemical composition and temperature of the expelled materials? Thus, a single photograph can become a detailed map of cosmic chaos and creativity. Images taken with the Hubble Space Telescope have marked a turning point in our visual understanding of Eta Carinae. Thanks to the extremely high resolution of its instruments, it is possible to distinguish knots and filaments of gas with astonishing precision. Can you imagine being able to observe the details of a stellar explosion that occurred more than 7,500 light-years away? That is precisely what these images have allowed, to contemplate the graphic testimony of a star on the brink of destruction, frozen in time and space. However, not everything is chaos in these photographs. Despite the violence and magnitude of the events that have shaped Eta Carinae, many of its images convey a serene, almost hypnotic beauty. This apparent contradiction is what fascinates both scientists and the general public. The most striking images of Eta Carinae are much more than mere astronomical portraits. They are windows into the life and death process of the most massive stars in the cosmos, reminding us how small we are in the face of the magnificence and mysteries of the universe. How did humanity manage to unravel so many secrets of Eta Carinae, such a distant and mysterious star? The answer lies largely in the Hubble Space Telescope. Launched in 1990, this observatory has revolutionized the way astronomers study Eta Carinae and its surroundings. Before Hubble, observations from Earth were limited by the atmosphere, which distorts and blocks certain types of light. Thanks to its location in space, Hubble provided a clear and unprecedented view of this star, allowing for the detailing of structures that were previously invisible. Hubble not only captured spectacular images, but also allowed for the analysis of the light from Eta Carinae at different wavelengths. Why is this so important? Because each part of the electromagnetic spectrum reveals distinct information. Ultraviolet shows hotter layers, visible light reveals shapes and structures, and infrared uncovers material hidden behind dense clouds of dust. With this data, scientists were able to study the complex homunculus nebula, the violent stellar winds, and the interactions between the stars in the binary system. In a way, Hubble acted as a cosmic detective, dissecting the scene of an astronomical crime unfolding in slow motion. One of Hubble's greatest contributions was tracking the changes of Eta Carinae in real time. By taking images and spectra every few years, astronomers observed how its eruptions evolve, how the expelled nebula expands, and how the brightness of the star varies. Can you imagine being able to see a galactic storm develop over decades? That is exactly what Hubble has allowed, documenting the living history of one of the most unstable and extreme stars known. Moreover, Hubble helped solve an old mystery. Is Eta Carinae really a single star? Thanks to its observations, we now know that it is a binary system of at least two massive stars. This revelation was key to understanding the violent phenomena we observe, as the interaction between the two produces shocks of stellar winds and unique luminous events. In summary, the role of the Hubble telescope has been like that of a privileged eye that, from its vantage point in space, has allowed us to contemplate and understand the complexity and beauty of Eta Carinae, bringing us a little closer to the secrets of the universe. When astronomers point their instruments beyond visible light and explore the universe using X-rays and gamma rays, they discover phenomena that would be impossible to perceive with the naked eye. But why is it so important to study Eta Carinae in these high energy ranges? The answer lies in the violent and extreme nature of this star. Eta Carinae is not only incredibly bright in the visible spectrum, but it is also one of the most powerful sources of X-rays and gamma rays in our galaxy. These rays tell us about processes occurring at millions of degrees and cosmic shocks of an intensity that is hard to imagine. Have you ever wondered what could cause such an emission of energy? In the case of Eta Carinae, the key lies in its colossal stellar winds. The two giant stars that comprise it eject material into space at speeds of thousands of kilometers per second. When these winds collide with each other, they generate shockwaves comparable to miniature supernova explosions. It is at these collision points where enormous amounts of X-rays are produced, allowing us to literally see the stellar battlefield and study extreme physics in action. The even more energetic gamma rays reveal the presence of particles accelerated nearly to the speed of light, making Eta Carinae a true natural cosmic accelerator. The study of Eta Carinae in X-rays and gamma rays has allowed us to answer fundamental questions while simultaneously opening new uncertainties. For example, how does the system expel so much energy without disintegrating? Space telescopes have detected periodic variations in X-ray emission that coincide with the orbit of the two stars, indicating that the interactions between them are even more complex than previously thought. Additionally, the detection of gamma rays suggests that the stellar winds not only collide, but also accelerate particles to extreme energies, a process similar to what occurs in supernova remnants or in the cores of active galaxies. But there are questions that still do not have definitive answers. Could these emissions be precursors to an imminent explosion? Or are they simply part of the life cycle of such a massive star? The truth is that observing Eta Carinae in X-rays and gamma rays is like having a window into the heart of a cosmic storm, where matter and energy intertwine in a violent and fascinating dance. Each new piece of data collected in these energy ranges brings us a little closer to understanding not only the fate of Eta Carinae, but also the most extreme processes occurring in the universe. What connection can a star like Eta Carinae have with the mysterious cosmic rays that traverse the universe? To understand this, it is first necessary to know what these rays are. Subatomic particles traveling at speeds close to that of light, coming from the most extreme corners of the cosmos. But where do these invisible travelers get so much energy? This is where Eta Carinae comes into play, one of the most intriguing candidates to be a source of high-energy cosmic rays within our galaxy. Astronomers have observed that very massive stellar systems, particularly those that experience violent eruptions and possess extremely powerful stellar winds, can accelerate protons and electrons to colossal energies. Eta Carinae is a perfect example of this class of stars. Its winds, so intense that they drag enormous amounts of matter into space, collide with each other and generate shock waves similar to those produced by a sonic boom here on Earth, but on a much larger scale. In these stellar collisions, particles can be launched at incredible speeds, becoming cosmic rays capable of traveling thousands of light years. But how do we know that Eta Carinae is actually involved in this process? Space telescopes observing in gamma rays have detected energetic emissions coming from the direction of Eta Carinae, consistent with the presence of accelerated particles. It's as if the star is functioning as a gigantic natural particle accelerator, far more powerful than any machine built by humans. It has even been found that the periods when Eta Carinae is most active coincide with peaks in the intensity of these gamma rays, reinforcing the hypothesis of its role as a source of cosmic rays. However, the mystery is far from being completely solved. Despite the evidence, it has not yet been possible to determine precisely how much energy Eta Carinae produces in the form of cosmic rays and what its contribution is to the total flow that reaches Earth. Could it be that other massive stars play an equally important role? Or are we facing an exceptional case? The truth is that each new piece of data about Eta Carinae brings us a little closer to deciphering the secrets of these ghostly particles, capable of traversing entire galaxies and impacting our own planet. The connection between Eta Carinae and cosmic rays reminds us that even over 7,500 light-years away, the violent processes of the most massive stars can influence the galactic environment and, indirectly, the history of life on Earth. In a way, every time a cosmic ray passes through our planet, it carries with it a trace of those stellar titans that, like Eta Carinae, continue to slowly explode in the far reaches of the cosmos. Is it possible that the explosion of a star located thousands of light-years away could have any effect on Earth? This is one of the most fascinating questions when we talk about Eta Carinae, one of the most likely candidates for a future massive supernova. Although its distance, approximately 7,500 light-years, seems enormous, the energy released by the death of such a colossal star evokes both awe and concern. Would Eta Carinae be capable of affecting our planet if it were to explode? To understand the potential impact, one must imagine the supernova as a gigantic cosmic beacon that for several weeks could outshine all the stars in the night sky. The visible radiation would be so intense that the explosion could be seen even in broad daylight, an astronomical spectacle only comparable to the most spectacular events in recorded history. However, the real risk to Earth does not lie in the visible light, but in the waves of high-energy radiation, such as gamma rays. This type of radiation can travel immense distances and, in theory, alter a planet's atmosphere if the source is close enough. Now, is Eta Carinae a direct threat to us? The short answer is no. Although a supernova of this magnitude would generate an impressive amount of gamma rays, the orientation of the energetic jets is crucial. If the jet does not point directly at Earth, the effects would be minimal. Even if we were aligned, the distance provides a natural shield. 7,500 light-years is enough for the radiation to disperse, reducing its potency to levels that would not pose a serious danger to life on Earth. Scientific simulations suggest that, in the worst-case scenario, we might observe a temporary increase in the ionization of the upper atmosphere, but not a catastrophic event. However, the explosion of Eta Carinae would have notable effects on science and technology. Telescopes and satellites would capture an avalanche of unprecedented data, from neutrinos to gravitational waves, allowing astrophysicists to study in real time the collapse of a giant star. Additionally, we could witness subtle changes in the Earth's ionosphere and perhaps unusual auroras at atypical latitudes. Beyond the risks, the explosion would be a unique opportunity to understand the stellar life cycle, detect newly formed chemical elements, and observe how a supernova enriches the interstellar medium. In short, the explosion of Eta Carinae would be an event of historical magnitude, visible across the planet, and a source of wonder for humanity. However, thanks to the distance and the orientation of its jets, it does not pose an existential threat to Earth. Rather, it would become a natural laboratory and the greatest spectacle of modern astronomy, reminding us that, although the cosmos can be violent, it is also an inexhaustible source of knowledge and wonder. What ingredients make up one of the most colossal and enigmatic stars in our galaxy? The chemical composition of Eta Carinae is, literally, a cosmic recipe capable of transforming the universe. At the heart of this star, the simplest elements, such as hydrogen and helium, are fused under extreme pressures and temperatures, releasing enormous amounts of energy. But what other elements are hidden in its layers? When astronomers analyze the light emitted by Eta Carinae, they discover the presence of much heavier elements: nitrogen, oxygen, carbon, silicon, sulfur, iron, and even traces of even more complex elements. Each of them is the product of nuclear reactions so violent that they can only occur in stars of such magnitude. Why is it so important to know the chemical composition of Eta Carinae? The answer goes far beyond mere curiosity. The heavy elements we detect in the atmosphere and stellar winds of Eta Carinae tell us the story of its evolution and the advanced state of its life cycle. Unlike smaller stars, where hydrogen dominates for a long time, in Eta Carinae there is already a large abundance of nitrogen and a relative scarcity of carbon and oxygen at the surface. This is a clear hint that the star has undergone a deep mixing of its internal layers, exposing materials that would normally be hidden. It's as if a pressure cooker had exploded, revealing the secret ingredients of the stellar stew. A fascinating fact is the enormous amount of material expelled by Eta Carinae in the form of stellar winds and during violent eruptions. These winds not only contain gas, but also dust and complex compounds, enriching the interstellar medium surrounding the star. Astronomers have detected aluminum hydride molecules, oxides, and even small silicate particles. This material will be the raw material for the formation of new stars and planets in the future, Eta Carinae, in a way, acts as an interstellar chemical factory, sewing the cosmos with the fundamental building blocks for life and galactic evolution. And how do we know all this? The key lies in the study of the spectrum of light emitted by Eta Carinae. By breaking down that light, scientists can identify the unique fingerprints of each chemical element. This has allowed not only the discovery of its chemical richness, but also the monitoring of changes in composition over time. This analysis reveals that Eta Carinae is in an advanced state of evolution, and that its atmosphere and the surrounding material are the result of very intense internal nuclear processes. In short, studying the chemical composition of Eta Carinae is like reading the personal diary of a giant star, uncovering each chapter of its turbulent existence and its legacy for the universe. How can a star become one of the most astonishing objects in the universe and, at the same time, be destined for an explosive death? The life cycle of massive stars, like Eta Carinae, is a spectacle that challenges our imagination and reveals the most extreme processes of nature. It all begins in a dense cloud of gas and dust, where gravity initiates a slow but relentless dance. As matter accumulates, temperature and pressure rise so much that in the heart of this protostar the first nuclear reactions ignite. But what differentiates a massive star from a star like our Sun? The answer lies in the amount of matter. A massive star can contain dozens of times the solar mass, making it a true factory of chemical elements and energy. For most of their lives, these titanic stars fuse hydrogen into helium in their cores, releasing enormous amounts of light and heat. But their gigantic size comes at a cost. They consume their fuel furiously and much faster than smaller stars. While the Sun can shine for several billion years, a massive star barely survives a few million before exhausting its reserves. And what happens when the hydrogen runs out? A tumultuous stage begins. The core contracts, the temperature skyrockets, and then the star starts fusing heavier elements, such as helium, carbon, and oxygen. Each new stage is shorter and more violent than the last, bringing the star closer to its inevitable end. In this process, the outer layers of the star can be expelled into space in powerful stellar winds or colossal eruptions, enriching the environment with materials that will later form new stars and planets. It's as if the star is sewing the universe with the basic ingredients for life, just before its final farewell. But what is the ultimate fate of such a massive star? When it can no longer fuse more elements, the core suddenly collapses under its own weight, generating a supernova explosion. This is one of the most energetic explosions known, capable of briefly outshining an entire galaxy and leaving behind a compact object, a neutron star, or, if the mass is sufficient, a black hole. The most fascinating aspect of this cycle is that, in a way, it is an act of cosmic recycling. The atoms of carbon, oxygen, and other elements that make up our bodies and our planet were once forged in the depths of massive stars like Eta Carinae. Thus, the life cycle of these stars is not just a story of destruction, but also of creation and renewal. Isn't it astonishing to think that the violent death of a stellar giant is, in fact, the seed of new beginnings for the cosmos? What happens when a monstrously massive star reaches the end of its life? In the case of Eta Carinae, the question is even more intriguing. Could this cosmic colossus collapse into a black hole? To answer, we must first understand that Eta Carinae is not an ordinary star. With an estimated mass of over 100 times that of the Sun, it far exceeds the minimum threshold necessary for a star to end its life in a cataclysmic explosion and potentially become a black hole. But why do astronomers believe this could be its final fate? When such a massive star exhausts its nuclear fuel, gravity takes control. The core, deprived of the pressure that holds it up, begins to compress brutally. If the core's mass is sufficient, not even the quantum pressure of neutrons can stop it. It's as if a mountain were trying to balance on a sheet of paper. Inevitably, it collapses under its own weight. At this point, the core can form a black hole, a region of space where gravity is so intense that not even light can escape. However, it's not that simple. Eta Carinae has lost an enormous amount of mass throughout its life, expelling violent stellar winds and undergoing titanic eruptions. This mass loss acts like a kind of extreme diet that could, in theory, prevent the star from retaining enough material to form a black hole upon death. But most models predict that, even with these losses, what remains will still be too massive to end up as a mere neutron star. One of the most fascinating questions in astrophysics then arises: what kind of black hole could Eta Carinae create? If the collapse occurs, it is likely to produce a massive stellar black hole, much larger than the average ones detected so far. Additionally, some scientists speculate that the final explosion could give rise to an even more energetic phenomenon, a gamma-ray burst, one of the most extreme events in the universe. However, due to the complexity of its binary system and the uncertainty about how much mass it will lose before its death, the exact fate of Eta Carinae remains an open mystery. In summary, all signs point to Eta Carinae having all the tickets to become a black hole when it finally explodes. But nature, as always, keeps its secrets until the very last moment. What we do know is that the day Eta Carinae reaches the final act of its existence, the universe will witness one of the most impressive spectacles ever seen. Will this be the birth of a new giant black hole? Only time and observation can give us the definitive answer. What secrets can the light traveling for thousands of years from a star to us hide? When we observe Eta Carinae, we are not just seeing its brightness, we are also deciphering a message encoded in the way that light vibrates. This is where light polarization comes into play, a fundamental tool for modern astronomers. But what does it mean for light to be polarized? It's as if, instead of dancing in all directions, the light waves align in a single direction, like a crowd moving in perfect synchrony behind an invisible signal. The polarization of light coming from Eta Carinae offers us a unique window to explore the geometry and dynamics of its surroundings. Why is this so relevant? Because light can be altered by the material it encounters, dust, gas, and magnetic fields near the star. By analyzing the polarization, scientists can reconstruct the shape of the expelled material, identify the presence of asymmetric structures, and even deduce how the powerful stellar winds of Eta Carinae interact with the surrounding material. It's like trying to reconstruct the shape of a statue just by observing the shadow it casts, but on a cosmic scale. One of the greatest findings from these studies has been the confirmation that the homunculus nebula, formed after the Great Eruption, has a truly complex and asymmetric structure. Polarization reveals that the material was not expelled uniformly, but rather concentrated in lobes and regions with very different densities. What does this tell us about the nature of Eta Carinae? That its eruptions and evolution do not follow simple patterns, but are marked by chaotic explosions and violent processes. Furthermore, variations in polarization over time allow astronomers to observe changes in the distribution of dust and gas, as if they could see a slow-motion movie of the star's environment. Could these measurements help us predict the final fate of Eta Carinae? Although the definitive answer does not yet exist, polarization provides essential clues about the interaction between the stars in the binary system and their immediate surroundings. Thanks to this approach, scientists can estimate how much material the star continues to lose and how that material influences its stability. Thus, the polarization of light is not only a fascinating physical phenomenon, but also an indispensable key to unraveling the mysteries surrounding one of the most extreme and mysterious stars in our galaxy. Can a star, on its own, influence the birth of other stars? In the case of Eta Carinae, the answer is a resounding yes. This colossal star is not only famous for its instability and explosive potential, but also for being a powerful cosmic architect in its surroundings. The incredible energy it releases, through intense stellar winds and past explosions, interacts directly with the interstellar gas and dust that surround it. But how can such a violent process give rise to new stars? It's as if an intense storm stirs a calm sea, creating waves that eventually form new lands on the shore. When Eta Carinae expels matter into space, It does so at astonishing speeds, generating shock waves that travel through the Carinae nebula. These waves act as natural compressors, squeezing nearby gas clouds. By increasing the pressure and density in certain regions of the nebula, the ideal conditions are created for the gas to collapse under its own gravity. Thus, the seeds of new stars are sown. This phenomenon is known as induced star formation, and it is one of the most fascinating processes in the evolution of galaxies. Is it possible that the birth of entire generations of stars depends on the fury of just one? In many areas of the Carinae nebula, astronomers have detected young clusters that seem to have emerged precisely in regions impacted by the expulsions of Eta Carinae. Through observations at different wavelengths, it has been confirmed that areas close to the star show clear signs of active star formation. It's as if the life cycle of Eta Carinae, far from being an isolated and destructive event, is actually a spark that ignites new fires in the cosmos. The influence of Eta Carinae on star formation has a double-edged sword. On one hand, its violent emissions can disperse gas and hinder the birth of new stars, but on the other, right at the edges where the pressure is sufficient, it can trigger the collapse necessary to create young stellar systems. Thus, Eta Carinae is not only a witness to galactic evolution, but actively participates in it, transforming its environment and ensuring that, despite its unstable nature, it leaves a legacy of new stars that one day could have planets and even life. Throughout history, Eta Carinae has been a source of wonder and mystery for those who have observed it. Did you know that in the 19th century, this star became one of the brightest objects in the night sky, surpassed only by Sirius and Canopus? During its famous Great Eruption, its brightness was such that even people without telescopes could see it with the naked eye, unleashing awe and speculation among astronomers and enthusiasts alike. Some thought they were witnessing the birth of a new star, or even the end of an old one, still not understanding the true nature of these celestial giants. But the oddities don't end there. There are accounts of navigators and explorers who, during long voyages across the southern hemisphere seas, used the glow of Eta Carinae as a guide. For them, this star was like a cosmic beacon in the vastness of the sky, marking the course on clear nights. Even some chroniclers of the time compared it to a torch in the southern sky, and its sudden increase in brightness became the subject of letters, diaries, and even poems. Another fascinating curiosity is that Eta Carinae was the protagonist of one of the first international scientific debates in modern astronomy. When its luminosity abruptly declined after the Great Eruption, many theories emerged to explain the phenomenon. Some suggested it was a stellar collision, while others speculated that it was surrounded by clouds of dust blocking its light. This enigma attracted the attention of scientists from Europe and America, who tried to decipher the star's erratic behavior based on observations and calculations done by hand. And what about the name? The term Eta Carinae comes from the Bayer nomenclature, used to identify stars within a constellation. But for centuries, it was known by other names and nicknames in different cultures. In southern Brazil and some regions of Australia, there are myths and legends that associate its changing brightness with omens and messages from the gods. Over the years, Eta Carinae has been a luminous enigma that has inspired both science and imagination, reminding us that even in the age of technology, the sky still holds secrets and raises questions that challenge our understanding. What happens when a colossal star exerts its gravitational influence on its surroundings? Eta Carinae, with a mass that exceeds several dozen times that of the Sun, is like an invisible force capable of sculpting the space around it. Its gravity not only keeps its own layers and its stellar companion bound together, but it also has a direct effect on the Carinae nebula, the gigantic cloak of gas and dust that surrounds it. It's as if Eta Carinae were a titan amidst a cloud, attracting, compressing, and altering interstellar matter. Could its presence change the fate of the entire region? The answer is yes. The gravitational influence of Eta Carinae acts like an engine that reorganizes the material of the nearby nebula. The clouds of gas and dust feel the gravitational pull of the star, which can lead to the formation of new clusters, the compression of dense regions, and in some cases, even the collapse of parts of the nebula to form future stars. It's a cosmic cycle where a massive star is not only a product of its environment, but also an active architect shaping the galactic neighborhood. Thus, Eta Carinae not only lives its own stellar drama, but also sows creative chaos in its surroundings. But the story doesn't end there. The extreme stellar winds and eruptions of Eta Carinae, when interacting with its powerful gravity, drive shockwaves through the nebula, displacing material over great distances. This phenomenon can be compared to a stone thrown into a pond. The waves expand, dragging along everything they encounter. In the case of Eta Carinae, gravity guides these waves and determines how far they will travel, changing the distribution of gas and dust in the nebula. What implications does this have for the formation of future planets and solar systems? The gravitational influence of Eta Carinae not only affects visible matter, but also generates regions of instability where new stellar systems could arise. Ultimately, its presence is a reminder of how invisible forces can have gigantic consequences on astronomical scales. When we look at the Carina Nebula and its whimsical shapes, we are witnessing the result of a delicate balance between creativity and destruction, all orchestrated by the gravity of a star that, even before exploding, is already leaving an indelible mark on the cosmos. What secrets does a star wrapped in dust and gas so dense that visible light cannot penetrate it hide? Eta Carinae, with its explosive and dramatic nature, has defied the direct gaze of astronomers for centuries, concealing its essence behind an opaque veil. But what if there were a way to see beyond, to discover what ordinary light does not reveal? Infrared study is that hidden passage, a kind of cosmic X-ray vision that allows us to peek into the heart of Eta Carinae and its surroundings. When observed in infrared, the universe transforms. The dust clouds that appear impenetrable to the naked eye become almost transparent, allowing scientists to uncover unexpected details. Why is this possible? Because infrared light has longer wavelengths, capable of penetrating the interstellar dust that blocks visible light. It's as if we had a pair of night vision goggles that let us see what happens in a dark room. Infrared reveals hidden structures and processes within the very heart of the Homunculus Nebula and in the regions surrounding Eta Carinae. Thanks to specialized observatories like the Spitzer Space Telescope and the Very Large Telescope, infrared studies have allowed the detection of enormous amounts of newly formed dust around Eta Carinae. But what does this mean? Interstellar dust is not just residue. It is the primordial material from which new stars and planets are born. Analyzing its composition allows us to understand the ingredients that the star expels into space and how these influence the evolution of its environment. Moreover, infrared has been key in identifying the presence of complex molecules, traces of hydrocarbons, and even water in the clouds surrounding the system, something that would be impossible to perceive with just visible light. However, infrared not only shows what is there, but also what is happening. Changes in temperature and the dynamics of gas and dust can be tracked accurately, revealing episodes of massive material ejection and energetic collisions between stellar winds. This allows astronomers to reconstruct the recent history of the star and predict its future evolution. To what extent do these discoveries help anticipate a possible explosion like a supernova? Each new observation in infrared provides a crucial piece to assemble the puzzle of one of the most enigmatic stellar systems in the galaxy. Thus, the infrared study of Eta Carinae becomes an irreplaceable tool for deciphering the mysteries of the most massive and violent stars in the universe. Without these eyes invisible to the human eye, much of the history and processes of Eta Carinae would remain hidden, like a sealed book that we are only now beginning to read in its deepest and brightest pages. How can a star be so chaotic and unpredictable? The answer lies in the complexity of its binary system. Eta Carinae is not a solitary star. It is made up of at least 2 giant stars that orbit each other in an intense and dangerous gravitational dance. Imagine 2 cosmic monsters of enormous mass, each with stellar winds so strong that they throw matter into space at incredible speeds. When these 2 colossal forces come close, their winds collide and form an extremely energetic collision zone, where matter is heated to millions of degrees and high-energy X-rays are emitted. This interaction is so violent that it distorts the surrounding material and creates unpredictable structures within the nebula that surrounds them. Why is it so complicated to study this system? The main challenge is that the 2 stars are separated by a relatively small distance in astronomical terms, but their orbit is very eccentric, meaning it is not perfectly circular. For most of the time, they are relatively far apart, but every 5.5 years they come dangerously close, like 2 race cars crossing at full speed on a tight curve. At those moments, the stellar winds meet more directly, producing bursts of energy and dramatic changes in the brightness and emissions of Eta Carinae. This periodic approach is responsible for many of the extreme phenomena that astronomers have observed. But how do scientists manage to distinguish between the 2 stars if they are so close together and surrounded by so much dust and gas? The key lies in analyzing the light that reaches us. By observing in different wavelengths, such as ultraviolet, infrared, and especially X-rays, astronomers can separate the energetic signatures of each star and piece together the puzzle. They have discovered that the primary star is a hypergiant of enormous mass, while its companion, although also massive, is somewhat smaller but much hotter. Their interactions not only affect the homunculus nebula, but also alter the way gas and dust are distributed in the environment, creating complex patterns that are still being deciphered today. The dynamics of Eta Carinae are so chaotic that each orbital cycle can bring new surprises. Theoretical models attempt to predict how this system will evolve, but reality often surpasses fiction. Could a particularly violent interaction trigger a new eruption or accelerate its path toward the final explosion? Each orbit is an opportunity to learn more about the extreme physics of massive stars. The study of this binary system not only reveals the secrets of Eta Carinae, but also helps to understand how the largest and most powerful stars in the universe evolve. What stories lie behind the name Eta Carinae? Although it may sound like a technical designation, behind this name is a fascinating blend of science, history, and mythology. The term Eta comes from the Bayer designation, a system created in the 17th century by the astronomer Johann Bayer to catalogue the brightest stars in each constellation using Greek letters. In theory, the letter indicates the order of brightness within the constellation. However, Eta Carinae defies that logic. It is not the brightest star in Carina, but it is the most intriguing. Why? Because its brightness has fluctuated so much over the centuries that its true magnitude remains a mystery, even for experts. And what about Carina? This name has roots that transport us to the era of great navigators and Greek mythology. Carina means keel in Latin, the central and fundamental part of a ship. In ancient times, astronomers saw in the sky a gigantic constellation called Argo Navis, representing the mythical ship Argo, with which Jason and the Argonauts sailed in search of the Golden Fleece. Argo Navis was so extensive that, centuries later, it was divided into 3 parts: Carina, Puppis, and Vela, corresponding to the keel, the stern, and the sails of the ship. Eta Carinae, therefore, occupies the honoured place in the keel of this stellar vessel. But are there legends or stories specifically associated with Eta Carinae? Although the star itself does not feature in ancient myths, its privileged location in the constellation of Carina links it to the symbolism of heroic journeys, adventure, and exploration. In various cultures of the southern hemisphere, where Eta Carinae is visible to the naked eye, it has been a reference point in nighttime navigation. For the Aboriginal Australians, the region of the Carina Nebula was seen as a sacred place, a portal to dreams and the beyond, although Eta Carinae, due to its variability, sometimes went unnoticed and at other times dazzled. And how has this name been used in popular culture? Although it is not as well known as Orion or Ursa Major, Eta Carinae has inspired science fiction novels, video games, and even songs, where its unpredictable and explosive nature makes it a symbol of mystery and power. In astronomical nomenclature, its name is a reminder of how science and tradition intertwine. A simple set of letters and words holds centuries of observation, mythology, and human wonder at the cosmos. Thus, every time we mention Eta Carinae, we evoke both the precision of modern astronomy and the ancestral fascination with the stories told by the sky. Is it possible that a star as massive and turbulent as Eta Carinae has managed to survive for so long, despite its violent eruptions and extreme instability? This question has intrigued astronomers for generations. Eta Carinae, on the brink of collapse for centuries, has resisted what seems to be its inevitable fate: a catastrophic explosion. But what mechanisms have allowed this star to defy expectations and continue shining, albeit in a chaotic manner? One of the most surprising factors in the survival of Eta Carinae is the way it has managed to shed enormous amounts of mass without completely self-destructing. To understand this, let's imagine a pressure cooker about to burst. If the steam finds an escape route, the explosion is avoided, even though the process is violent. Something similar happens with Eta Carinae. Its monumental eruptions, like the famous one from the 19th century, act as cosmic pressure valves. By expelling a significant fraction of its material into space, the star reduces pressure and delays its final fate. Thus, the very loss of mass becomes a survival mechanism. But it's not just the loss of mass that keeps Eta Carinae in this delicate balance. The interaction with its companion in the binary system also plays a crucial role. The gravitational forces between the two stars generate stellar tides that redistribute energy and matter, altering the rhythm of the eruptions and, at times, temporarily stabilizing the system. This cosmic dance, although chaotic, allows Eta Carinae to continue existing in a state of controlled instability, as if it were constantly walking a tightrope between stellar life and death. Does this mean that Eta Carinae has found the formula for immortality? Absolutely not. Its survival is, in reality, a race against time. Each eruption, each loss of mass, and each alteration in its core brings it one step closer to its final destiny. However, the star has demonstrated an astonishing ability to endure. This precarious balance will not last forever, but it offers us a unique window to study the extreme processes that precede the collapse of the most massive stars in the universe. Thus, Eta Carinae not only survives, it teaches us, with every pulse and glow, about the limits of stellar resilience. What kind of instruments does humanity need to unravel the secrets of an extraordinary star like Eta Carinae? It's not enough to just look up at the sky with a conventional telescope. The study of this star has driven the development and use of highly advanced observation technologies, capable of capturing extreme phenomena and details impossible to appreciate with the naked eye. From large aperture optical telescopes to X-ray and gamma-ray detectors, the research on Eta Carinae is an example of how modern astrophysics relies on technological innovation to explore the universe. To capture the complexity of Eta Carinae, astronomers have turned to space telescopes like Hubble, which allows observations in wavelengths inaccessible from the Earth's surface due to the atmosphere. Hubble has been crucial in revealing the structure of the Homunculus Nebula and the details of stellar winds, thanks to its ability to obtain extremely high-resolution images. But how are the most energetic phenomena, such as bursts and high-energy emissions, studied? This is where observatories like Chandra and XMM Newton come into play, detecting X-rays from the collisions of stellar winds and the intense radiation generated in the region close to the star. The advancement is not limited to space. On Earth, instruments like high-resolution spectrographs installed in observatories in Chile and Hawaii have allowed for an astonishing level of detail in analyzing the light from Eta Carinae. These spectrographs work as if they were breaking down the star's light into an extremely precise rainbow, enabling the determination of chemical composition, wind speeds, and the presence of heavy elements. Additionally, radio telescopes like ALMA have been essential in studying the coal dust and gas expelled during the Great Eruption of the 19th century, revealing how the material is distributed in the surrounding space. And what about the latest technologies? Infrared detectors, for example, have allowed us to look through the dust that obscures parts of Eta Carinae in visible light, revealing previously unexplored areas. Polarimetry, a technique that analyzes the orientation of light, has helped map the geometry of the nebula and understand how the star interacts with its environment. Even artificial intelligence is beginning to play a key role, helping to process enormous volumes of data and identify patterns that humans might overlook. Thus, the study of Eta Carinae depends not only on human ingenuity, but also on a symphony of technologies that, when combined, allow us to decipher the secrets of one of the most fascinating stars in the cosmos. What happens when a massive star like Eta Carinae interacts with the surrounding space? This stellar colossus not only shines brightly, it is also one of the main factories of interstellar matter in our galaxy. By expelling enormous amounts of gas and dust in each of its eruptions and through extreme stellar winds, Eta Carinae literally enriches the cosmic environment. It's as if a cosmic storm sweeps through the neighborhood, spreading new essential ingredients for life and the formation of future stars. But why is this exchange of material so relevant? The interstellar matter coming from Eta Carinae contains a mix of heavy elements, the result of nuclear processes inside the star. When these materials are thrown into space, they contribute to the chemistry of the interstellar medium. Elements like carbon, oxygen, and iron, essential for planet formation and eventually life, arise from such phenomena. In fact, if we look at our own planet and everything around us, we can trace much of its atoms back to explosions and eruptions of stars like Eta Carinae. Isn't it fascinating to think that everything that exists on Earth was once in the heart of a giant star? The clouds of gas and dust left behind by Eta Carinae play a fundamental role in the evolution of its environment. These remnants not only enrich space, but can also trigger the formation of new stars. Imagine a shockwave that, as it moves forward, compresses the interstellar material and initiates a cycle of star birth. Thus, Eta Carinae not only slowly destroys itself, but also sows the seeds for the next generation of stars and planets in the galaxy. However, this process also raises intriguing questions. To what extent do the violent emissions of Eta Carinae alter the balance of the interstellar medium? Could a single star change the fate of an entire region of the galaxy? Astronomers study these flows of matter to understand how they influence galactic dynamics and the emergence of new solar systems. Every particle expelled by Eta Carinae is a clue about the cycle of cosmic life and death, reminding us that the universe is a constantly changing stage, where the end of one star can be the beginning of many others. What is the true impact of a star like Eta Carinae on the evolution of an entire galaxy? To understand it, we must first think of galaxies as enormous cosmic cities in constant transformation, where massive stars like Eta Carinae are the main engines of change. These stars are much more than mere points of light. They function as factories of chemical elements and catalysts of fundamental processes that determine the fate of their galactic environment. When a colossal star like Eta Carinae lives and dies, its life is marked by the generation and release of heavy elements such as carbon, oxygen, and iron. These materials not only enrich the interstellar medium, but also seed the molecular clouds from which future generations of stars and planets will be born. It's as if Eta Carinae, with every eruption and every stellar wind, is fertilizing the galactic soil for new forms of stellar life. Why is this so relevant? Because without this recycling, the universe would run out of the necessary ingredients for chemical diversity, and eventually for the possibility of life. But the influence of Eta Carinae doesn't end there. Its powerful stellar winds and explosions shake and reshape the gas and dust clouds around it, triggering the formation of new stars while also preventing others from forming. It's a delicate balance, a kind of cosmic gardening, where what one star destroys may be exactly what another needs to be born. If we think of the galaxy as an ecosystem, Eta Carinae would be like a storm that, while ravaging with its force, also leaves behind the ideal conditions for rebirth. Moreover, the energy released by Eta Carinae and other similar stars contributes to the global dynamics of the Milky Way. The pressure and heat they generate can influence the rotation of galactic gas, the structure of the spiral arms, and the distribution of dark matter, although the latter remains one of science's great mysteries. Could a single star change the fate of an entire galaxy? Perhaps not on its own, but together, stars like Eta Carinae are the invisible architects of the cosmos, responsible for sculpting the landscape of galaxies over millions of years. Ultimately, studying the role of Eta Carinae in galactic evolution is an attempt to read the secret history of the Milky Way and understand how extreme, seemingly chaotic events are essential for shaping the order and beauty we observe in the universe. Who would have thought that the violence of a star could be the origin of galactic harmony? What mysteries are currently keeping astronomers busy when studying Eta Carinae? Research on this star does not stop, and new questions arise each year. For example, one of the main focuses of current studies is to understand the exact dynamics of its binary system. Although we know that Eta Carinae is made up of at least two massive stars, the details of their orbits and how their stellar winds interact still hold enigmas. Scientists are employing state-of-the-art computer simulations to model these interactions, trying to predict how the collision of their winds produces variable and intense X-ray emissions, as if it were a titanic struggle between two celestial titans. Another fascinating line of research is the constant monitoring of its brightness variability. Why does Eta Carinae change its luminosity on such short and long timescales? To answer this, astronomers around the world coordinate observation campaigns across different wavelengths, from infrared to gamma rays. This monitoring allows for the detection of any sudden variations, as if one were watching the pulse of a cosmic patient that could suffer a crisis at any moment. Additionally, artificial intelligence algorithms are being developed to analyze vast amounts of data and anticipate behavioral patterns that could signal new eruptive events. The study of the chemical composition of the homunculus nebula, the material expelled during the Great Eruption, also occupies a central place in current investigations. What secrets does that interstellar gas hold? By analyzing the light it emits and absorbs, astronomers seek traces of heavy elements and complex molecules, which helps reconstruct the history of the star's outer layers and understand how massive stars enrich the interstellar medium. This search is akin to analyzing the ashes of a volcano to deduce its eruptive history and its impact on the environment. Finally, one of the great challenges is to predict the final fate of Eta Carinae. When will the long-awaited supernova explosion occur? International groups are combining observations from space and ground-based telescopes with theoretical models to estimate whether the star is nearing that critical point. Researchers are also looking for precursor signals, such as changes in surface temperature or neutrino emissions, that could indicate the imminence of collapse. Thus, Eta Carinae remains a natural laboratory that challenges modern astrophysics, driving new technologies and global collaborations in the quest to unravel the secrets of the universe's most extreme stars. Despite decades of intense observations, Eta Carinae remains an enigma for modern astronomy. Why does this star, which should have exploded in a supernova long ago according to conventional theories, continue to defy its final fate? Current models struggle to explain how it can lose so much mass and energy over centuries and yet remain intact. Is it that we still do not fully understand the internal mechanisms governing the most massive stars in the universe, or is there some special condition in Eta Carinae that makes it unique? Another major mystery revolves around its binary system. How do the extreme interactions between the two stars affect their evolution and stability? The collisions of their stellar winds generate energy storms that challenge theoretical predictions. Could these interactions be the key to understanding the unpredictable variations in its brightness and the formation of complex structures like the Homunculus Nebula? Furthermore, the precise mass of each component is still unknown, and whether there are more hidden stars in the system opens the possibility that we are dealing with an even more complex system than we imagined. The future of Eta Carinae is, of course, one of the most intriguing questions. When will it finally explode as a supernova or hypernova? Astronomers estimate that it could happen at any moment within the next few 100,000 years, but there is no way to predict the exact timing. Will this event be visible from Earth with the naked eye, illuminating the skies like a cosmic beacon, or will its final burst be lost among the flashes of other massive stars? Additionally, what types of elements and particles will it release in its explosion? And how will these affect the galactic environment and potentially even the formation of new stars and planets? Finally, there remains the question of the hidden mysteries in the data that we have yet to decipher. What secrets do the X-ray, gamma, and infrared spectra hold that we have not yet fully interpreted? What role does Eta Carinae play in the generation of high-energy cosmic rays that bombard our planet? Each answer obtained seems to open new doors to the mystery, reminding us that while we have made significant progress in our understanding of the cosmos, countless questions still await answers from future generations of astronomers. Why can a star like Eta Carinae fascinate both scientists and enthusiasts alike? Perhaps because it represents one of the greatest enigmas of the cosmos, the life and death of giant stars. Eta Carinae is not just a star. It is a natural laboratory where the most extreme physics manifests before our eyes. Its colossal eruptions and variable brightness remind us that the universe is in constant change, and that even the most imposing celestial bodies have an uncertain fate. Can the fate of Eta Carinae teach us something about our own place in the galaxy? When we observe its tumultuous history and its influence on the interstellar environment, we discover that massive stars do not just live and die. They forge the elements that will eventually form planets and may give rise to life. It's as if each explosion, each stellar wind, and each pulse of light are chapters of a much larger story, where we are merely the attentive readers. What will happen when Eta Carinae finally reaches the end of its life? Astronomers debate whether it will collapse into a black hole or leave behind a supernova so bright that it would be visible even to the naked eye from Earth. But beyond the visual spectacle, what is truly astonishing is that we still do not know many of the secrets that this star holds. As if the universe invites us to keep exploring, to never settle for what we already know. Ultimately, Eta Carinae is a reminder that the universe is full of mysteries waiting to be deciphered. It shows us that, although science has advanced tremendously, there will always be questions that challenge our understanding. Thus, as Eta Carinae continues its slow explosion, it inspires us to look at the sky with renewed curiosity, knowing that each new observation could forever change what we think we know about the cosmos.